In this video, we are going to talk about gas resistive sensors.
To begin, we need to know what a resistive sensor is. As well, these are which vary a resistance depending on a measurement variable. A classification of this sensor is made depending on this variable as shown in the table. In this way, it can be said that the gas resistive sensors are in the classification of the chemical variable to be measured.
On this occasion, we will talk about gas resistive sensors, which are composed of semiconductor metal oxide, such as tin dioxide.
The principle of operation can be found in the image. On the left side, when there is an absence of gas, the oxygen in the air is negatively charged with the tin dioxide electrons. On the right side of the image, when the sensor is in the presence of a gas, the surface density of the negatively charged oxygen decreases, causing the potential barrier to reduce, thus reducing the electrical resistance.
Sensor characteristics.
The gases they detect are oxygen, fuel gases such as propane, methane, and hydrogen, toxic gases such as carbon dioxide or ammonia, organic solvents such as alcohol and toluene, contaminants such as carbon dioxide and chlorofluorocarbons.
Sensor equation. The relationship between the resistance of the sensor and the gas concentration can be seen in this equation, where Rs is the resistance of the sensor, K and A are constant, and C is the gas concentration.
Measuring circuit. These sensors have 4 terminals. 2 are from the sensor itself and 2 are from the heating electrodes, so that the temperature is adequate for the chemical reactions.
Similarities and differences with non-resistive gas sensors.
Capacity. They are more sensitive than resistive sensors, so they require less complex circuits than those of a resistive sensors. Thermal. These sensors measure absolute humidity instead of relative humidity, so they measure the change in the conductivity of the air due to humidity.
Gravimetrics. They measure the mass of an air sample compared to an equal volume of dry air. It is a more accurate method to determine the moisture content. Absorption. They use chemical substances that, after absorbing, excel the moisture according to the circumstances. Electrical. If an alternating voltage is applied to them, the fabric is heated and a part of the water content evaporates, setting the degree of humidity accurately.
Applications. The application given to this type of sensors can be in greenhouses, industrial spaces, egg incubators, saunas, or museums, but mainly it is used for alarms detecting the level of gas concentration. The circuit for this application is as follows.